All right, so 65. We have two boxes connected together by a string. The two boxes are being pulled by a 50 Newton force. We're given that M1 is 10 kilograms. This guy right here, the box of peaches, that's 10 kilograms. M2 is 20 kilograms. And for A, they want us to find the acceleration of each box and the tension in this middle string right here. Now look, what do we know about the acceleration of each box? The same or different? The same, because they're connected by a string, right? Now, they say up here that it's a frictionless horizontal surface. So that makes things real nice. But notice in part B says repeat the problem where there is friction. So A is going to be lickety-split. It's much easier if there's no friction. So let's do part A. What's the acceleration and what's the tension? So for a problem like this, if there's no friction, what you can do is you can go, all right, well look, this 50 Newton force right here, does that 50 Newton force know that it's pulling two objects? What is the 50 Newton force basically pulling?
30.
A 30 kilogram mass, okay? So you could solve part A by going like this. This guy here is 30 just make it a 30 kilogram mass being pulled by a 50 Newton force. So we'll say F equals 50 newtons. There's no friction, so nothing points to the left. And then we have mg down, normal force up. Okay. The vertical is not going to matter here. The y direction is not going to factor in. And the reason why is because, are we being asked to find normal force? No. Which way is the acceleration of the object going to be? The acceleration is going to be which way? In the x. Friction's not. If friction were present, then we would have to solve for normal force. Because why? Because what's the equation for friction? Mu times normal force. So anyway, let's just follow the steps. There's free body diagram. Let's sum forces x. What's our only x force? 50. That's it. There's only one x force. Sum of the forces always equals ma. So look, you take this right here. A is going to be the 50 Newton force divided by m. Remember, Newton is kilogram meter per second squared. The mass is 30 because we combine them. So this gives an acceleration of 1.6 repeating. Okay? And now that we know that acceleration, what we can do is come back here and find tension. Right? So to find the tension in the string, we have to unsimplify. Right? We have to put them back to being two separate masses. So to find the tension in the string, you can either focus on M1 or you can focus on M2. It does not matter. You'll get the same answer no matter which mass you focus on. So which one should we focus on, M1 or M2? Doesn't matter. M1. All right, so here's M1, the 10 kilogram guy. Here's the 10 kilogram box of peaches. So what are the forces on M1?
Tension.
You got mg down. You got normal force up, and then you have tension. The rope is pulling to the right. And there's no friction, so there's no force to the left. So now for this situation, we sum the forces in the x. We don't even need the y direction here. What's the only x force?
Tension.
T. So what is that going to equal? ma. Right? And we now know what a is. So T equals ma, so that's going to be 10 kilograms times our acceleration, which we now know, 1.6 repeating. So this gives us a tension of 16.6 repeating newtons. Okay? Could we have found that tension by focusing on M2? Yeah, let's just do it. I want you guys to see this. This is important. So look at, we could have gotten the tension by focusing on the other mass. So by focusing on the other mass, what are the forces? Well, it's not going to matter, but let's show it. Normal force in mg, So here we have the 20 kilogram guy. This is the 20 kilogram mass. So what are the X forces? 50 newtons to the right. What's the force to the left? Tension, right? There's that rope here. Which way is that rope acting on the box of apples? To the left. So now when you sum the forces in the X direction, you're going to get 50 newtons minus T equals MA. Right? Solve this for T. You're going to get 50 minus MA. 50 newtons minus 20 kilograms. And then the acceleration's 1.6 repeating. And you get the exact same answer. So you could use M1 or M2 to get the tension in between. Okay? All right, now let's go to part B. So any questions on part A? Part B is going to be trickier because there's friction. So we're going to do the whole thing again. So here's M1. M1 is 10 kilogram. Here's M2, which is 20 kilogram. Now look, with friction being present, you can't lump them into one mass, right? Because that would make one big heavy object. So you got to keep these guys separately. You got to keep them separate. All right, so let's do the free body diagram for each mass. So we have normal force up, and I'm going to call that normal force 1, right? Fn1. M1g down, which is 98. Okay, what's pulling M1 to the right? Tension. And then how about to the left? Friction. Friction is now present. So this is going to be friction 1, which equals mu times normal force 1. There's two different normal forces here. There's the normal force on M1. There's the normal force on M2. Okay, for M2, we got M2G, which is 196. We got our 50 Newton force to the right. We have a normal force up, which I'm going to call normal force 2. We have tension to the left, and we have friction to the left. For that friction, that's going to be friction 2 equals mu times normal force 2. And the coefficients are the same for both objects, right? The coefficients are the same for both objects. All right, so now we sum forces. Okay, so summing the forces for M1, we're going to have, so x direction for M1, what are our x forces? T minus friction 1 equals what? M1A. And then in the y direction, you have normal force 1 minus M1G. Oh, but what is M1G? 98 equals M1A. But look, this is a y acceleration, this is an x acceleration. Are these objects accelerating vertically?
No.
No. So what can we do to the y acceleration?
Take it away.
Cross it to 0. Take it away. All right, now we go to M2. Sum forces x. So this is going to be 50 newtons minus friction 2 minus tension equals M2A. And then we sum forces y. Normal force 2 minus 196, that's M2G, equals M2A. What happens to this A right here? It goes to 0. There's no vertical acceleration. Okay, so now we got our, hey, in my opinion, hard part's done. We did free body diagram. We summed the forces. The remainder of the problem is working the algebra. From here, it's all algebra. So, let's figure out what these frictions are, guys. What's friction 1 and what's friction 2? Okay, so how do we, before we find friction 1, what do we have to get? Normal force 1. What is normal force 1? Fn1 is equal to what?
98.
98. Down here, what is normal force 2? 196. So you got to get those normal forces. The coefficient for both objects is 0.1. So what's friction 1 going to be equal to? 9.8. What's friction 2 going to be equal to? 19.6, right? So now we can plug those into our equations. Okay, so dudes, we got two equations, two unknowns. I'm going to solve each of these two equations. I'm going to solve for t. So we get t equals m1a plus friction 1. Here we're going to get t equals 50 minus friction 2 minus m2a. All right, so we're going to set this and this equal because the tensions are equal. m1a plus friction 1 equals 50 minus friction 2 minus m2a. So now we can solve this for a. A will be 50 minus friction 2 minus friction 1 minus m, oops, back up. Is that it? Yeah. Divided by m1 plus m2. Check my algebra here, is that right? Okay, so you plug the numbers in and you get an acceleration of 0.69. Okay, so now that we have the acceleration, how could we get the tension?
Plug it in.
You plug it back in here or here. You have two equations for tension. So plug in here. When you plug the numbers in, you're going to get 16.6 for tension. All right. That was my final homework problem for Chapter 4.